Morning students, today we are going to discuss IIT-JEE NEET Foundation. The laws of motion. The topics are apparent weight of a body, acceleration of the block on the horizontal surface. See, apparent weight is nothing but the weight of a body changes due to some external factors. So there is certain weight is going to be changed. So usually the weight is the gravitational force exerted by the mass of a body which is on the surface of the earth. There is certain change in the weight due to some other factors like acceleration and if a body is at rest of if a body. So there is some external factors which influence the weight of a body. That change in the weight, what we will call it as a apparent weight. So coming to the apparent weight of a body, the topic in the laws of motion, this is a very important topic. See, laws of motion, Newton's laws, Newton's first law, Newton's second law, Newton's third law. In the Newton's first law, the object is said to be at rest, something like every body is at rest or uniform motion unless compelled by an external force. Newton's second law, acceleration depends upon mass and force. Then third law, for every action there is an equal and opposite reaction. So in the Newton's laws, there is some important concepts like apparent weight. See, what is apparent weight? Apparent weight of a body. So usually there is a change in the weight of a body. So the cases are there here. The body when it is in the lift, a person is in the lift, what will be the weight of the person usually? So the first case is when the person is there in the stationary lift. If a person or a body, if it is in the stationary lift, so the lift is stationary, lift is not moving, lift is just is at rest. So then what will be the apparent weight? So there is apparent weight here. If you observe the apparent weight of a body inside the lift is equal to the actual weight. So there is certain, let us take the apparent weight here, nothing but the net weight. So due to that net weight becomes 0. The net weight becomes 0. So the apparent weight is equal to the net weight. For example, this is the lift. So body is there in the lift. The body object which is there in the lift of mass m. There is a gravitational force acts on the body, it is mg. Opposite to the gravitational force, normal reaction. So the normal reaction, the net force, if you observe, the net force is equal to the normal reaction minus the weight of a body, that is equal to 0. The net force is equal to 0 because the body is at rest, there is no acceleration. So mass into acceleration will be 0, hence the net force will be 0. Then apparent weight here, normal reaction is nothing but apparent weight is equal to weight of a body. Apparent weight is equal to weight of a body when the lift is at rest. This because there is no forces act on the body. There is no forces act on the body. Here if you observe, see here the conditions if you take. See, there is no forces acts on the body. Here no forces acts on the body. So the person weights, for example, 70 grams is there, 70 kgs. The same 70 kgs, okay, so will be as an apparent weight. So if the lift is stationary, the same 70 kg will be there. There is no change in the weight of a body. So apparent weight is equal to, so actual weight of a body. Apparent weight is equal to actual weight of a body when the lift is stationary. This is the first case. See, usually in the elevators, so there is lift is moving upwards, lift is coming downwards, etc. Those are the cases here. See, stationary lift, person is there, so the normal reaction and mg which is going to be there. So according to the condition, the apparent weight equal to the actual weight of a body. The same apparent weight equal to the weight of a body here. The apparent weight, whatever the weight is there, mg, the same weight it is equal to the apparent weight in the case of the lift is stationary. See, coming to the next, the lift is, okay, so moving accelerated upwards. The lift is accelerated upwards. When the lift is accelerated upwards, so there is a gravity which is going to be act downwards, but actual weight and apparent weight, if you compare, apparent weight will be greater than the actual weight. Apparent weight will be, see, in this case, if you observe, the apparent weight will be greater than the actual weight. It means that actual weight, if it is taken as mg, then apparent weight equal to, see here, apparent weight equal to, the apparent weight equal to, that is normal reaction, let us say R is equal to m into a plus g. R is equal to m into a plus g. So here the acceleration, a is called acceleration, g is the acceleration due to gravity. The apparent weight will be greater than the weight of a body. Apparent weight will be greater than the weight of a body. This is due to the combined, see, if you observe here, this is due to the combined effect of the gravity and upward acceleration of the lift. This is the combined effect of the acceleration due to gravity and the upward acceleration, and as well as the gravity, which is going to be, these two factors are considered. The apparent weight will be counterbalanced by the net force acting on the body. The apparent weight will be counterbalanced. The balances it. So there are two different forces if you observe here. See here, the lift is moving upwards due to the upward motion of the lift. Due to the upward motion of the lift, there is some force which is going to be there. That is force due to acceleration. That is mass into acceleration. Mass into acceleration. There is a normal reaction. R is acting upwards. The gravitational force mg is acting downwards. So according to this formula, R minus mg is equal to net force. The net force is nothing but ma. Net force is nothing but ma. Then R is equal to, the reactional force is equal to ma plus mg. So m into a plus g. M into a plus g. You can understand here, the apparent weight is greater than the actual weight. The actual weight is weight equal to mg. Weight equal to mg if the lift is moving with an acceleration a upwards. If lift is moving with an acceleration a upwards. So this is the another case in the, for the apparent weight of a body when the body object is placed in the lift. So next case is the lift is accelerating downwards. When lift is moving downwards, when it is accelerating downwards, so what will be the apparent weight? See, this is just converse to the earlier process. When lift is moving downwards, the apparent weight will be less than the actual weight. Apparent weight will be less than the actual weight. The difference between here, the gravity and acceleration, okay, so that difference only which gives the, so apparent weight, the gravitational force and the net force, mass into acceleration. So that difference which gives this, see, the normal force exerted by the floor decreases to balance the, okay, the net force. Here the apparent weight will be less than the, apparent weight will be less than the actual weight. It means that in this case apparent weight will be less than the normal weight of a body. Normal weight is nothing but mg. So here the formula, apparent weight formula, m equal to, so a minus g. You can write as a minus g, or you can take, okay, so see, there is a, if you observe carefully here, the lift is moving downwards and mg is also acting downwards. So both are, it is okay, see, something like R minus mg equal to minus ma. R minus mg equal to minus ma. So that's why you will get it as here, if you observe the formula, R minus mg equal to minus ma. You can write, so R is equal to mg minus ma. Okay, so you please take this. So g minus a, here the value of A is less than G, that you have to remember, the value of A is less than G, acceleration of the lift is less than the acceleration due to gravity. When it is the case, so the formula is m into G minus A, when m into G minus A, that you have to remember when lift is accelerating downwards. So next the case is when the lift is moving with constant velocity, there is no acceleration. Constant velocity is nothing but, see, there is no acceleration. If there is no acceleration, the apparent weight is equal to actual weight of a body. In this case, apparent weight equal to actual weight of a body. Apparent weight, whatever apparent weight will be equal to normal weight of a body, because there is no acceleration. So there is no net force acting on a body, hence the apparent weight can be written as mass into acceleration due to gravity. The person will feel here, okay, so weightless. So actual weight such as scenario, something like when lift is falling downwards. So when lift is falling downwards also similar case. When lift is falling downwards, this is the constant velocity. It is stationary when the lift is moving with a constant velocity, or when lift is stationary, both are in the same cases. See, apparent weight of a body when lift is falling freely, this is another case. When the lift is falling freely, the acceleration due to gravity is equal to the acceleration of a body. See, acceleration and acceleration due to gravity both are same. So then apparent weight of a body in the lift will be 0. That is called weightlessness. The apparent weight of a body is equal to the, see, when lift is falling downwards, when the lift is falling downwards, see, falling downwards, the formula you know. So that is the G value, so equal to A value. So the R equal to m into G minus A. So A equal to G, because the acceleration of a body while it is falling, so acceleration is equal to gravity, hence the m into G minus G, then the weight of a body, apparent weight of a body is equal to 0. This is called weightlessness. The total weight it is going to be, so make it as nullified, that is weightlessness. This is because the lift is, see, having here everything inside including the body and accelerating downwards with the same acceleration due to gravity. So there are the cases just now we discussed for the apparent weights. The first case, if you observe, the first case is when the lift is stationary. This is the first case. See, in the stationary lift, the weight of a body, apparent weight of a body is equal to the actual weight of a body. Is equal to the actual weight of a body. And the second case, see, this is the first case. The second case, when the lift is moving upwards, when the lift is moving upwards, the apparent weight of a body in the lift is greater than the actual weight of a body. It means the apparent weight equal to m into G plus A. M into G plus A is the formula. That's why the apparent weight will be greater than the actual weight of a body. This is the second case. Then third case, the third case is lift is accelerating downwards. When lift is accelerating downwards, the apparent weight will be less than the normal weight of a body. So it means that apparent weight is equal to R equal to m into G minus A. The acceleration is less than acceleration due to gravity. R is equal to m into G minus A will be the formula. That is apparent weight. So this apparent weight will be less than the actual weight of a body when lift is moving, accelerating downwards. Coming to the next case, when lift is moving with constant velocity, when the lift is moving with constant velocity, hence there is no acceleration, apparent weight is equal to the actual weight of a body. It is just like a lift is stationary, both are similar. In the lift is stationary, the apparent weight is equal to actual weight of a body. When lift is moving with constant velocity, apparent weight is equal to actual weight of a body. Then the last case, if you take the apparent weight of a body when lift falling freely, when the body is falling freely, the acceleration is equal to acceleration due to gravity, hence the apparent weight is equal to 0. Apparent weight is equal to 0. So these are the cases for the, so when the body is having some, so there is some effect in the weight of a body due to the motion, due to the something, when lift is accelerating upwards, lift is accelerating downwards, lift is stationary, etc. So this is the first topic here. Then go to the second topic, acceleration of a block on the smooth surface. See what is meant by this here, what is the acceleration formula we are going to use when the block is there on the smooth surface. Smooth surface is nothing but the friction is nullified, no friction on the surface. So frictional force we are not going to consider here. So frictional force will be 0. So hence only, see, there is a net force we are going to take. So let us say when the block is placed on the smooth surface, when the block is placed on the smooth surface, it means there is no friction between the block and the surface. That is the meaning, smooth surface and rough surface. These are the two surfaces. Smooth surface if there is no friction. Rough surface if there is a friction on the surface. So when there is a friction between the block and the surface, then that we will call it as a rough surface. When there is no friction between the block and the surface, that we will call it as a smooth surface. See, if the block is there on the smooth surface, so first point you have to remember, there is no friction between the block and the surface. Then second point, the force acting on the block by the applied force. See what will be the external force which is going to be acted, that we have to consider. What are the forces are acting on the block, that should be taken into consideration. See, basically these type of problems we can solve by using Newton's second law of motion. What is Newton's second law of motion? That is force equal to mass into acceleration. Force equal to mass into acceleration. See, the rate of change of momentum of a body is equal to force. So force formula, according to Newton's law, the acceleration, mathematically acceleration is equal to net force divided by mass. The net force divided by mass, what we will call it as a Newton's second law of motion. See here the formula, acceleration will be equal to the, acceleration will be, see, something like acceleration equal to the net force divided by mass of a body. That formula we have to use. Find out the acceleration when the block is there on the smooth surface. So we know that according to Newton's second law, acceleration is directly proportional to force and inversely proportional to mass. Let us take, so there is a block is there, so which is pulled by the force F. There is a block is there which is pulled by the force F. That force is a vector quantity. Force is having magnitude as well as direction. So magnitude and direction. So we have to consider here, the direction is resolved into two components. One is horizontal component, another is vertical component. The force, the horizontal component is, so F cos alpha, and vertical component is F sin alpha. Alpha is the angle of inclination. Here the force is applied by the block. Let us take, this is the block. So you are pulling the object with a force F. You are pulling an object with a force F. So there is a horizontal component resolved into two components. One is cos alpha. Alpha is the angle of inclination what we are pulling the object. So now the F cos alpha is the horizontal component and F sin alpha is the vertical component. Vertical component is sin alpha, F sin alpha, horizontal component is F cos alpha. So if you consider these two things, if you just here, you can understand when a block is pulled, okay, so with an angle alpha relative to the horizontal direction, the object will be experienced as component of the forces. There are two components, horizontal component and as well as vertical component. The magnitude of these components can be determined trigonometrically. You can find out trigonometrically. So the trigonometrical functions like sin alpha, cos alpha. Sin alpha usually we will take it as, so vertical component, cos alpha we will take it as horizontal component. The force horizontal is F cos alpha. The vertical component of the force F vertical can be found using F sin alpha. The same thing is explained. The acceleration of a body can be determined. So by separating into two different components like horizontal component and vertical component. So horizontal component of acceleration is equal to the F cos alpha upon m. You are going to get acceleration of a body. This, if you observe here, see, A horizontal means what? Acceleration along, because acceleration is also a vector quantity. See, like force, acceleration is also a vector quantity. So horizontal component of acceleration and vertical component of, horizontal component of acceleration A horizontal is equal to F net horizontal by m. F net horizontal is nothing but F cos alpha divided by m. Acceleration is equal to here, acceleration along x axis is equal to Fx by m. Simply, so you have to write like this. Fx is nothing but what? Fx is F cos alpha upon m. F cos alpha upon m. So similarly, vertical component is what? Fy. That is vertical component here. Let us object is having, there is a weight. Is also, if you taken into consideration. So let us take the object is having mass m. So the weight of a body mg is going to act. So there is a force which is going to act. F is the force. So the F resolved into alpha is the angle of inclination, resolved into two components, that is F cos alpha and another will be F sin alpha. F cos alpha, F sin alpha. If you observe carefully, the net force in the vertical direction, F sin alpha minus mg, the net force here, okay, F sin alpha minus mg. That's why, see, vertical acceleration along y axis is vertical F sin alpha minus mg upon mass of a body. This is the vertical acceleration, but horizontal acceleration is only F cos alpha is there. So you will get horizontal acceleration along x axis is F cos alpha upon m. F cos alpha upon m. Acceleration along the horizontal is F cos alpha upon m. Vertical acceleration is F sin alpha minus mg divided by m. So these are the different two components of accelerations. So as similarly force, how there are two components along vertical and as well as horizontal, similarly acceleration also will have two components. When the block is there on the smooth surface, it is applied by some force. See, formulas you have to take into in this way, in this manner, the horizontal force and vertical force, horizontal force upon m, all these formulas should be considered. So something like a block is pulled by a person here, if you observe, in the vertical F sin alpha minus mg by m, so in the horizontal F cos alpha by m. In summary, when a pull is acting on an object at an angle alpha, the horizontal and vertical components of acceleration which is going to be exhibit here, horizontal component of acceleration and vertical component of acceleration. The magnitude of accelerations you can find by using the above formulas. So in this manner you can calculate the accelerations. So I hope you understand the video. Thank you very much. Thanks for watching.